record on this computer. So today you don't necessarily have to take notes, but we are going to be talking about something a tiny bit different from what we already took notes on. We're going to be talking about a specific term called the constant of proportionality, which are big fancy words to say it's a number. So what a constant of proportionality is, let's go ahead and start with that. This is going to be a really short lecture today, actually. Like the stuff we're actually talking about isn't going to be very long. And then I'm going to try something a little bit new with an activity today. So the constant of proportionality is the multiplier that relates two variables in a proportional relationship. Those are a lot of big, fancy words that are super mathy. So I'm going to show you what it means through some examples, and hopefully it'll make a little bit more sense. Let's continue. So for example, if a car is moving at the rate shown in the table below, the constant of proportionality would be its speed. So here we have a table that shows us, oh, got a couple more people coming in. Here we have a table that shows us a car driving. The number of hours that it's driven is on the bottom, and the number of miles that it's gone is on the top. Okay, so in math, most of the time, what is it, the lecturess? I lecture myself all the time. So in math, generally speaking, we're going to choose one of these variables to be our y and one of them to be our x. In this case, this would probably be our y and this would probably be our x. It doesn't necessarily matter, but this is how you would usually see it in a table. So we've got miles on top, we've got hours on the bottom, and we want to calculate the speed. So we can calculate the speed really, really easily here. I mean, we've got, it goes 30 miles in 1 hour, it goes 60 miles in 2 hours, it goes 90, and it goes 120. We'll talk more about how you do this in graphs specifically in just a little bit, but basically you can calculate a constant of proportionality from any of this. In this case, it would just be 30. So this car is going 30 miles per hour. Now, one of the things I do want you to keep in mind is the constant of proportionality is actually the number that you would multiply your x by in order to get your y. So in this case, if we multiply 1 by 30, we get 30. If we multiply 2 by 30, we get 60. If we multiply 3 by 30, we get 90. And if we multiply 4 by 30, we get 120. So we can kind of think of the constant of proportionality as it's the multiplier that relates the variables, in this case, x and y. And it only works in a proportional relationship. So if we had a table that wasn't a proportional relationship, why wouldn't the constant of proportionality work? Can anybody tell me? Does anybody have an idea?
Because it's not equal.
Right. So if we had one that wasn't the same, right? Like let's say the next point was 130 to 5. If we tried to multiply this by 30 again, it's not going to work, right? 5 times 30 is 150, not 130. So if your relationship is not direct variation or directly proportional, then there is no constant of proportionality. So this only works for direct variation and proportional relationships. So what we're going to do is we're going to do a little bit of practice. So tables are probably the most common way that you're going to see this, but we will do it from graphs and from formulas as well. So to calculate a constant of proportionality from a table, simply find the ratio of y to x. Now remember, you have to make sure that there is direct variation first. So this was what we were practicing yesterday in the math space and the IXL. The IXL, by the way, was a lot shorter for those of you that were doing the math space. So if you were struggling with math space, you might want to try the IXL, but that's up to you. So direct variation, you have to make sure that everything in your table has the same ratio of y to x. Now, I'll give you a hint for all of these ones. I already made them direct variation so we could practice the new stuff. But if you don't know how to figure this part out, that's something worth staying after class and asking me about and getting some extra practice on. So let's start with the first one. What we want to do is figure out what our multiplier is to go from x to y. Now this one's pretty easy, but we're going to do the same thing. We're going to take y and we're going to divide it by x. So for this first one, we don't have a 1 anywhere, so we're going to just choose whichever point we want. It doesn't matter. We can pick any of them, but let's start with the smallest one. So 9 over 3, in this case, that's just 3. If we did 12 over 4, 12 divided by 4 is also 3, 15 divided by 5, and so on and so forth. And as you guys can see, they're always going to be the same thing. So what is the constant of proportionality?
The same thing over and over again?
Right, but what is the actual number for this table, for the green table up here?
3.
Constant of proportionality is just 3. Yep, it's just that simple. So what I want you guys to do is for this one, we'll call this A. I want you guys to tell me what is the constant of proportionality for the blue table. This one's a little tougher. Not quite, Jasmine. Remember to divide it by your x. So this one, your answer will be either a decimal or a fraction. Good, Janie. Good, Addie, although you just put it to everybody chat, so now everybody gets to see it. But okay. So you're also
literally about to put 2.5 in right before she said it, and I'm like, she kind of just ruined it.
That's all right. So again, all we're doing is we're taking our y value. In this case, we could do 50 if we're picking the first point, dividing it by our x, which is 20. 50 divided by 20 is just 2.5. You could also write it as 5/2, whichever you wanted to do. And again, if you chose other points, so 100 divided by 40, you'd get the same thing. You can plug any of these into a calculator. You're going to get the same constant proportionality. And in this case, that is 2.5. Now, this last problem, there's going to be 3 different answers I want you guys to give me. So A, I want you to fill in this number. B, I want you to fill in this number. C, I want you to fill in that number. And then D, I want you to tell me the constant of proportionality. So you should have 4 answers for this one. I'll give you guys a little bit of time to do it. But this table does have direct variation. They all have direct variation, like I said earlier. So we know that the ratio of each one is going to be the same. Addie, I'm not sure what your first answer is supposed to be, but the other ones are all right. Yeah, okay, there you go. Taven, good on A. Jasmine, that is good on A, but you put it in everybody chat again. B, Taven is a little bit off. Tristan, check your B, but otherwise you got him. You didn't answer A. Oh, Jasmine's just trying to ruin it. Okay.
If I didn't get it right, it's probably because the thing is just like right in front of it, and I was kind of just guessing it.
Gotcha. Taven, that is correct for C. Oh, yikes. You okay, Charlotte?
Yeah, I'm fine now. It just kind of hurt at the moment.
That doesn't sound like fun. Sawyer, those are all correct. What's the constant of proportionality? And also, why did you put it in everyone chat? Sawyer kind of just ruined it for everybody. That's all right. Not a big deal. So he didn't say the constant of proportionality, which means everybody should still be able to get that one for me. So everybody should still be able to do D, but A is in fact 9, B is 36, and C is 21.
21.
And I'll talk about Y in just a second.
It's 1/2.
It's not 1/2.
Well, no. You're right. It's yeah. Mm-hmm. Well, yes, and yeah.
I don't know what you're saying, Tristan. A lot of yes. Yes, Dakota, that's correct. Good job. Jessica, no. That is not correct. Especially not the part about being bored. This is the most fun thing you've ever done. You can't be bored right now. It's impossible. You're lying. Okay, so I'm going to start by when you're doing these tables, technically it's actually smartest to calculate the constant of proportionality first. So again, we could take 6 divided by 3 because we're doing y over x. So 6 divided by 3 is just 2. You could also do 12 divided by 6, which is also just 2. So in this case, the constant of proportionality is 2. So that one's already done. Then what we do is to go from x to y, we multiply by 2. So if we're going this way, it's going to be times 2. And if we're going the other way, it's going to be divided by 2. So for this one, we've got, or for A, we have 18. We're going from y to x, so we're going to divide by 2. And 18 divided by 2 is just 9. For part B, we've got 18. We're going to double it. That goes to 36. And for 42, we're going to take half of it. It goes to 21. Okay. So next up, from equations, this one is super, super easy. So again, remember that in order to find the constant of proportionality, it has to be a direct variation equation. And direct variation equations have the form y equals mx, where m is just some number. So remember, if you like add to it, if you add 3, or if you add a squared, or if you do divided by or something like that, it's no longer direct variation. So you have to make sure you have a direct variation equation first. Then calculating it from there is super easy. The m represents the slope. And in direct variation equations, this is also the constant of proportionality. So you just take whatever number is in front of the x. One thing I do want to remind all of you guys about though, so the slope is equal to the constant of proportionality, which is equal to m. This is only in direct variation. This is not true in other linear equations. You're going to learn more about those next year. But I just want to make sure you guys remember it has to be direct variation to have a constant of proportionality. So it has to be written in this form. One other thing I want you guys to remember is remember that slopes, if it's going up like this, it's positive. If it's going down like this, it's negative. And if it's going straight across like this, then it is 0. So that's another important thing to remember. Now, what I want you guys to do is tell me, what is the constant of proportionality in this? In this, call it A, B, and C. Okay. Everybody should be able to do these ones. Good, Janie. What? No, Jasmine, we just started the new unit. We're not having a test today. Addie went into everyone chat again. Today is the last day of the week, Taven, but we're gonna be doing other stuff. This unit will end next week because we only have a 4-day week next week too. Colton good on A, Addie good on all of them except for the last one. Should be careful. Let me write this more clearly.
2 things. I don't know why, but whenever I press the chat so I can type in chat, it does full screen for some reason.
Huh. That's weird. Sorry about that. What's the other thing?
Oh, I got it. Oh, also, were mine right?
I don't remember what they were. But Jasmine, you got all of them. Colton, those are all good.
I can retype mine.
Let me scroll up. Tristan, yeah, those are all good. Okay. So again, we're just taking whatever the number is in front of x. So y equals 4x, this one is 4. Y equals 2/3 x, this one is 2/3. And y equals negative 2x, this one is negative 2. So it's that simple. You just take the number that's in front of the x. Really nothing to those. Now, the last one is a little bit tougher. Constant of proportionality from graphs. Now, remember when we were doing the problem, the first problem back when we were taking notes, we had the ski trip to Mount Hood. We had a graph that looked like this. So we could have calculated constant of proportionalities for individual parts of this. So from here to here, from here to here, and then from here down, but not for the whole thing. And I'll show you why in just a second. So to find the constant of proportionality from a graph, make sure the graph has direct variation. Again, that's necessary for all of these things. In order to have a constant of proportionality, you always have to have direct variation. So the line has to be a straight line and it has to go through the origin, 0, 0. Then we're going to find a point on the graph and take its ratio of y to x, just like you would from a table. Alternatively, you can count the places you move up from the graph and divide that by the places you move to the right. Both of those will work. And remember that slopes can be positive, negative, and 0. And again, this is the positive slope. This is a negative slope. This is a slope of 0. Okay, so let's look at some examples. So first of all, what I want you guys to do is tell me which of these does not have direct variation. One of these graphs does not have direct variation.
It's the
Hold on, don't say it out loud.
D. Oh.
And somebody said it out loud. Okay, whoever said D, why is it D?
Sorry, I was saying it before you said that, and it's because it doesn't start at the 0. It starts up at 8, and
Right.
it's
So
completely
this
off.
one, it doesn't start at 0, 0. It doesn't hit the origin. This one hits the origin right here. This one hits the origin right here. And this one hits the origin right here. You'll notice I gave you two different types of graphs. So we've got the 4-quadrant graphs over here and then the single quadrant graphs over here. Either one of these works, and either one of them can have direct variation. It's just that they have to go through that origin no matter what kind of graph they are. Okay, so next thing I want to ask is the slope of A positive, negative, or 0?
Are we allowed to say it out loud or type it?
Type it, please.
TJ. It was supposed to be in private.
I just realized that.
So this one, I'm seeing a decent number of answers, but this graph, remember, you're only looking left to right. So you're only looking in one direction. And this one is going up as we go left to right. So this has a positive slope. What about B? Is it positive, negative, or 0? Awesome. There we go. So far, everybody I've seen. Sawyer, you're on fire, dude. Everything in all chat. So this one is also positive. It's going
The one
up as we
time
go left
I
to right.
don't mess it up.
All right. What about C? Positive, negative, or 0? So this one, as we go left to right, the line is going down. So this one is negative. And then the last one, positive, negative, or 0. Yep, good. It is also negative. So the line is going down as we go left to right. So a slope of 0, a lot of people were saying this on occasion, a slope of 0 would have to go straight across like that.
Never mind.
Okay. Never mind. Okay. All right. We'll never mind. So D does not have a constant of proportionality because it is not direct variation. So we can say none over here. Now we want to calculate the constant of proportionality for A, B, and C. So what we're going to do is we're going to pick any point on the graph except for 0, 0, and we're going to take the ratio of the y to x. Now, these are kind of small, so I'm going to mark out some points for you guys. So here's this one. It's the point 1, 3. This one, we've got a point at 1, 4 and 2, 8. So I'll write out the 2, 8. This one, I'm going to give you a negative point. So we're going to have negative 4, 2. So I want you all to try to calculate the constant of proportionality for each of these graphs. And remember, constant of proportionality is the y over x. Why can't I see the chat? There we go. Addie, you've got them backwards. Jeannie, that's correct. Dakota, those are also backwards. Jasmine, they should be fractions, not just numbers. Well, actually, I guess they could just be numbers, but they shouldn't be points. There you go, Dakota. Addie and Jeannie, reduce that. Reduce the fraction that you just put in. There you go, Jamie. There you go, Addie. Yep, Dakota, that's correct. Okay, so hopefully you all remember that points are written x comma y. So the y value of the point is written second. And we're doing y divided by x. So in this case, we have 3 divided by 1, which is just 3. So the constant of proportionality for our first graph is 3. That is also equal to the slope. You'll notice that it's a positive number, and our slope is positive. If we look at letter B, we've got 2 comma 8. So we have 8 over 2. 8 divided by 2 is just 4. So our constant of proportionality is 4. And again, we've got a positive number for the constant of proportionality. We've got a positive slope. Now, C is probably the most difficult one.
Wait. Really quickly before you answer this one, because it's a negative, wouldn't you multiply, not divide?
No, you're still going to divide.
Really?
Yep. So what we're going to have here is 2 over negative 4. Now, a lot of people were writing the answer to this one like this, 1 over negative 2. That's not technically wrong, but the way you're supposed to write it is with the negative out in front. So it should be negative 1/2. So our constant of proportionality here is negative 1/2. And again, we'll notice we have a negative number for our constant of proportionality, and we have a slope that is going down. Okay, so that's actually all the new material for today. Now, we're going to do something a tiny bit different as far as activity stuff goes. Although, we went a little longer than I wanted to, maybe not. Okay, I'm going to make it an optional activity. So give me just a second to stop recording.